Building cloud-native applications is not easy, and that is because the cloud can be a very complex environment. There are too many choices, and there's usually not a clear path on how to get started. But fortunately, there's a brand new tool known as .NET Aspire, which has been specifically designed to help us address all of those challenges of cloud-native development. So today I'm going to show you how to turn a full-stack ASP.NET Core application into a cloud-native application by using .NET Aspire. And let's start by taking a look at the application that we want to turn into a cloud-native application. So this application here is a fairly simple CRUD-style application that has both a backend API, an ASP.NET Core API, and a Blazor frontend. It's all based in .NET 8. It uses a PostgreSQL database, and it also has a dependency on Azure storage. Now, the application is already running in my box, so let me show you it in action. It's right here. It's a very simple catalog of video games. And as you can see, you can come here and just look at the catalog, but also you can go ahead and well, create a brand new game. So let's say we create Super Mario Bros. 3. It's going to be like that. Let's say it's 1999. Let's say it's from 1988. And you can come here and pick an image from my catalog of images that I have over here. I'll hit on save, and that stores the game, as you can see in next page, page 2, so it has pagination. So it stores the game in the PostgreSQL database, and the image actually being rendered from Azure storage, right? And you can always go ahead and use the search to look for a game. For instance, I'm going to look for Final, and that's going to return one of the games, Final Fantasy 14, right? I can go ahead and just clear this, and that takes us back here. And also, of course, you can also go ahead and delete a game. So I'm going to delete Super Mario Bros. 3 here, delete, and that takes the game away, right? So fairly standard CRUD application. And but I think it's good to understand clearly what are the dependencies between the different components of this application. So let me show you this very quickly over here. So like I said, this is a full stack application. It has an ASP.NET Core backend, right? An API that has a dependency in a PostgreSQL database, right? But then we also have a Blazor frontend, and this is a Blazor static server rendered, right? It's a new style of application in .NET 8. And it has a dependency on Azure storage because that's where all the images are stored. And finally, we have, of course, the last component will be the browser, which is the client that's actually trying to access data in the front end, right? And so this is the application. And we're saying that we want to turn it into a cloud-native application. But what does it mean to actually turn cloud-native? What is cloud-native? So basically, cloud-native means that if an application is cloud-native, it means that it has been specifically designed to run in the cloud. And it is ready to deal with the many challenges that are present in the cloud. And those challenges go from many vectors, right? For instance, you have the theme of observability, right? So how can you tell what's going on with the application when it's no longer in your box or in your server or in your data center, in your internet? This is in the cloud. So how can you tell what's going on with the application, right? All the metrics, all the logging, how do you troubleshoot? So that's very important, and that's part of a cloud-native application. There's also the theme of resiliency, right? Your application is going to be talking to multiple services all over the place, and many times those services are not going to behave properly. So is your application ready to deal with those situations? So that's a theme of resiliency, and that's a key part of a cloud-native application. There's also the theme of scalability, right? So if you go to the cloud, it means that you should be ready to go ahead and scale limitlessly, right? So the application should be very elastic in such a way that it can handle any sorts of demands or loads that can change over time, right? Specifically, also in typical seasons, like let's say a Black Friday season, there's a lot of load, so you should be able to scale according to that. And finally, there's also the theme of manageability, right? So how are you able to fine tune or change things in the application while it's deployed in the cloud? So, and these are just a few things. There are many other things involved in cloud native, right? But that's kind of the idea. So a cloud native application is an application that has been designed to run in the cloud, not in your box, not in your data center, in your server, but in the cloud, right? And it, like as you could imagine, it is very challenging because of all these things here. So that is why the Microsoft.NET team created this brand new tool that's known as .NET Aspire. And in their terms, it is basically a cloud-ready stack for building observable, production-ready distributed applications, right? And so today I'm going to show you exactly how to use this tooling to turn an application into a cloud-native application using .NET Aspire, right? And so let's go back into our code. And so this is our browser. Let's go into our code. And so let's go ahead and turn this application into a cloud-native application. So the first thing that we're going to need need is a brand new component from .NET, right? And like I said, you do need to have at least .NET 8 installed, .NET 8 ECK, otherwise you'll not be able to use this tooling here, right? And so now let's go ahead and open up our terminal over here, and let me collapse this. I'm going to stop my application. So let me collapse this and this right here. And so what we're going to do, and let me just go up one directory right there. You're going to need to install a new workload, which is the Aspire workload. So all you have to do is just say .NET workload install Aspire, right? So that's going to bring in all of the new components that you're going to need in your SDK to go ahead and create Aspire-based application. It's kind of a new kind of application, distributed application that you can create with .NET Aspire, right? So the workload is installed, and so because of that, we can do now the following. So I can just do .NET new list, and if we expand our screen here, we're going to see that at the top, we are going to find a new set of applications. So right here, if we can see there is this new .NET Aspire application, and also the Aspire starter application. The starter one is kind of a blueprint of how you can create a backend for the front end with a few customizations. But in our case, we're going to be using the Aspire one to add the projects that we need into our existing solution. We are taking one existing application into an Aspire application. You could go ahead and use a starter to create a brand new one if you wanted to, right? And so let's go ahead and take advantage of this template. And let me actually take a quick look at this is our structure over there. So what I'm going to do is just say down here, and so .NET new Aspire, right? So .NET Aspire is going to provision these new projects that we're going to need. So I'll hit enter. And as you're going to see on the left side, we're going to have a set of new projects created right there. So let me expand this a little bit, right? And so notice that we now have this brand new app host project and this new service defaults project. So those are the new projects. Plus, it also created a brand new solution that is right there. Okay, it would be great that it didn't create a solution because we don't need it. So I'm going to actually delete this solution over here. We're not going to use it. And by the way, if you're using Visual Studio, there are wizards and stuff to kind of simplify a few things, but we don't do Visual Studio here. We do VS Code, right? So we want to know exactly what's going on behind the scenes. And so no magic here. So what we're going to do now is to add these brand new projects into our existing solution. So I'm going to open up my Solution Explorer down here, right? So I'm going to open up this, and as you can see, I have the API and the front end over here. So I'm going to right click on this. I'm going to do our existing project, and we're going to go ahead and add our app host right there. And we're going to also add our service defaults project right here. Okay, so now we have a complete all of our projects right there. Now, what are these projects about? Why do we need these projects? Well, let's take a quick look. This one here called Service Defaults is pretty much a library of extension methods that are going to be very useful to turn your application into a cloud native application. What does that mean? Well, we have this extension method here, right, at Service Defaults, that what it does is it brings in all of these behaviors that are typical of a cloud native application that usually you will add one by one by hand into your app. But in this case, this method here adds everything that you usually need just in one shot with kind of an opinionated set of settings, but still is incredibly useful help to create your cloud native application. For instance, it configures OpenTelemetry for all of the telemetry information that you want to send for later, monitor your application in the cloud. It adds health checks, right? Oh, let me scroll down a little bit. So yeah, it adds health checks, as you can see right here, so that the orchestrator in the cloud can easily tell what is the health of your application. It adds service discovery, so that each of the components or the resources in your cloud native application can get in touch with other resources or other services or microservices in your application. It also configures your HTTP client, so that anytime your app talks to other services, it uses these typical resiliency behaviors like the ones that Poly will usually use, right? So things like exponential backoff, circuit breakers, bulkheads, all the timeouts, right? All of those are now part of .NET itself. And with this method here at Standard Resiliency Handler, you can get all of those default behaviors for free, right? And so you can configure and fine tune them if you need to, but the defaults are good to get started. All right. We also have this map default endpoints method over here, which what it's going to do is just map the typical health check endpoints that are expected in of an application that's going to be deployed into the cloud, right? And there are a few other things here. We're not going to take a look at everything in there, but basically that's the idea of service default. We're going to see how to use that in a moment. The other project is AppHost, and AppHost is it's pretty much going to be the host of your application, of your distributed application in your box, but also it's going to be the application that's going to compose all of the components of the distributed application in such a way that later is going to be used to define how to get this application deployed into the cloud, right? And so, but we're going to go back into this in a moment. I think we should start with the services in service defaults. So the first thing that we have to do is that we need to make sure that both our API and our frontend, they have to get a dependency on service defaults, right? So that they can start using their methods. So let's go ahead and do that. So let's take API. Let's do project reference into service defaults, and let's take also frontend, take a project reference into service defaults, right? So now both of them can use the service defaults. So to use them, all you have to do, so let's go into program CS over here, okay? And so there's a bunch of code over here. I'm going to go across all this code. What I want to do is just go ahead and add these additional methods. So here what we want to do is just the following. We're going to say builder.add service defaults, right? Okay, so that's the one method. Like I said, this is a method that adds OpenTelemetry, default health checks, all that stuff. So we want to do that. And then also we want to go, let me go actually all the way down here just before app run, right? It doesn't matter too much the location for this one here, but I want to put it at the very end so it's very clear where that we're adding this additional behavior. And what you want to do here is just say app.map default endpoints, right? Like I said, this is pretty much for health checks. That's all it is. Now, so that gets your application ready to start receiving all default behaviors for cloud native development, and also to be able to discover other services across the entire application. Now, we have to do the same thing with the other app, right? So this is the backend. Let's do the same thing with the front end. So let me switch into front end. Let's go to program.cs. And let's go ahead and do at the very top, again, add service defaults. And then let me copy the other line. Map default endpoints right here, right? Now let's go back into the API over here. And then one thing that I mentioned, of course, is that we are using a PostgreSQL database, right? And that's, you can see over here, that I am adding the services to be able to use PostgreSQL in my application. Now, one thing about Cloud Native is that you want to start not just using these components that are very handy, but you want to use improved versions of this default dependencies that have all these additional behaviors also for telemetry, for resiliency, all of these behavior, because when you go to the cloud, you want to make sure that if you're going to talk to a PostgreSQL database, you're able to do retries, right? And you're able to monitor what's going on with that PostgreSQL database and stuff like that, right? The default libraries for these services are not going to have those behaviors, but that Aspire brings in components so that you can actually wrap the default libraries and use these additional behaviors. Now, to know what exact components you need to use here, what you want to do is just go into the documentation for the Aspire. You're going to see that there's a section here, down here. As you can see, you have for storage, database, messaging, caching, security, all these things. So those are the components that the Aspire team has already built and you can integrate into your application. So in our case, we want to deal with database, right? So database, and in our case, is PostgreSQL Entity Framework Core. That's what we're using, right? So what you want to do, first thing is usually going to be add a NuGet package. And here you can see, this is the wrapper NuGet package to use PostgreSQL by using the Aspire conventions. So I'm just going to copy this. So I'm going to install this NuGet package in my application. So let me go, and actually before doing that, let's take a quick look at what we have referenced right now. Notice that today we are using this NuGet package right here. This is the MPG SQL, the one that you would use for PostgreSQL. We no longer need this one because we're going to be using the brand new one from the Aspire. So I just removed that one, and now we're going to go into the gamestore.api directory, and I'm going to paste, that's the line that we just copied from the documentation, hit enter, and that's going to add the reference to this brand new NuGet package. Like I said, this is a NuGet package that is able to wrap the default behaviors of PostgreSQL, but adding all of the resiliency, monitoring, telemetry, all these things that you want to have for each component, right? It's right there. So now that we have this, what we can do is the following. So let me show you. Instead of having to read the connection string like this, right, and then invoke this other method for MPG SQL, what you can do is this. You can just say now builder dot add MPG DB context, and then I'm just going to copy the line that I have. Actually, it's just a type. So this is the game store context. And then you want to give it what is going to be the name of the connection, right? The name of the connection that's going to be used. In this case, it's just a game store, right? Now, like I said, this is going to add, and this is going to use the wrapper library. Now, the one here in the parameter is the name, is the connection name. That we have to define that connection name somewhere in configuration. So if you go now into Explorer, and we go into app.settings.json, here you're going to see how we're doing things today, right? So pretty much what we have here is a connection string for the game store database. Now, I do have the connection string here because there is no password, right? So that I'm using kind of the mode of Postgres in my local Docker container where you don't need a password. That's why I have it here. Otherwise, I will not put the connection string here. But with .NET Aspire, there is a different schema that you can use so that your application can run both in your box and also, as a standalone, but also it can run in the Aspire host, as we're going to do later. So what I'm going to do is just change this structure here to the one that Aspire recommends. So let me actually copy that very quickly from here. All right, I'm going to copy and paste that here. All right. And so as you can see, this is a well-known convention that the .NET Aspire library for PostgreSQL understands right away, right? So it knows that it has to use this connection string. The connection string is a same string, but we're using a new convention. As because we use this specific set of hierarchy, it means that this call here is going to be able to start taking advantage of that connection over there, all right? And so yeah, that's one thing. Now, the next thing, let's see. The next thing is going to be in the front end, right? So let's switch now into front end. Down here, front end. All right. And what we want to do is to go into our app settings.json file. And the interesting thing here is that, of course, today we're using this configuration here, game store API URL. This is the configuration that we're using to tell the front end how to talk to the backend, right? Which is a very standard thing to do. But of course, what happens is that now, eventually, when you move to the cloud, you have to figure out, okay, so now how do I tell the front end, okay, so that it has to talk to the backend, right? Where is the backend? With .NET Aspire, we don't want to deal with these problems. What we want to do is to just define something, some sort of string here that later on .NET Aspire is going to figure out both locally and in the cloud where exactly that service lives, where is that dependency it lives today, right? So what you can do here, instead of doing this, what you can do is say something like just backend, right? This is the backend. It could be any string, it doesn't matter. You're going to see how we're going to configure this in a moment. But basically, we're not going to be tying any piece of infrastructure to things in our local box anymore. These are going to be defined by the .NET Aspire host and later on in the cloud by the artifacts that .NET Aspire is going to generate, right? So that's that. And then what we want to do now is to, we want to go now into our app host project. So let me go into app host right here, right? And like I said, this is a project where we're going to be composing our distributed application, right? And so this is going to be super useful for be able to run the application in the app host locally, but also to tell later how we're going to be distributing this into the cloud. So what you want to do here is to use this brand new distributed application object here to create a builder. And then we want to tell the .NET Aspire, okay, so what are the components, what are the resources in our application? And so let's start by adding the database, right? So we need a database here. So we're going to do the following. We're going to say that this is Postgres. Let's say this is builder. The first thing that we're going to need, of course, is a container, right? Usually in your box, you're going to be using a Docker container to interact with this with a database, right? Now, what we need to provide here is just some sort of identifier for this specific resource, for this container. So here, let's just call it Postgres, right? And then following that, we want to define what is going to be the actual database that we're going to be using in our application. So for that, let's just say add database, right? And then here is where we want to use exactly that that connection name that we defined before in the code. So if you take a look very quickly at the API, which is the one that's going to be using this, if you go back into Program CS, remember that we use right here game store, right? So this is the connection name. So that connection name we want to be using over there in app host, right there for the name, okay? And so the really cool thing about this is that this by itself is going to go ahead and stand up that Docker container, right, with that database so that it is ready for the application. You don't have to go figure out where do I pull down the Postgres Docker container, how do I run it, right, do we need a password or not, right, how do I configure it, how do we attach it to my application, all these things, you don't have to figure that out. So these two lines here are going to take care of all that stuff for you automatically, right? So that is one of the key benefits of using this tool here, right? Now, the next resource that we have to define here is our backend and our frontend. But before doing that, let's not forget that we need a reference from our app host project into each of these other resources, right? So let's go ahead and do that very quickly. So let's go back into Solution Explorer and let's make sure that we do app host. Let's do a project reference into API and app host project reference into frontend. Okay, so that is very important because that is what's going to enable us to define that connection between the different components right here in the app host. So let's go ahead and define the following. So backend is going to be builder add project, right? And here you're going to find that there's new metadata that you can use now to define, to add your project into this application. So you're going to find projects. And then you can say, you can choose between the different projects that have been referenced by the app host. In this case, what you want to use is the API, right? Game Store API. And then we want to give it some name. Now, this name that we're going to be using here is very important because this is the name that later the frontend is going to use to be able to talk to the backend without having to know exactly where it lives. Now, what is going to be that name? Well, if you remember, when we went into the frontend, right? Here's the frontend, app.json, we said that we wanted to be able to reach the backend by just using HTTP backend. So backend is going to be the name that you have to use in this configuration that we're setting up right now. So let me close this and let's go back into app host, let's collapse this. And so that's what we're going to be using right there. And so let me go ahead and let's close this like that. And so, okay, so that adds the project. And then what you also want to do here is to define that the backend wants to use our Postgres database, right? We need to do the connection. So because of that, we can say with reference, and the reference is going to be into Postgres, right? With a reference to Postgres, right? So that set up that connection, right? And so as you can see, we are kind of building these relationships between the different projects. Now, of course, we also want to have defined here the frontend, and the frontend has to talk to that backend, right? And so let's go ahead and do that. And I think this suggestion is pretty accurate. So let's go ahead and take it. So builder add project. So we want to use actually game store that frontend, right? And this is going to be defined as our frontend. And as you can see, it does have a reference into the backend, right? And so, yeah, so those are pretty much all of the connections that we want to define in this here. And I wanted to show you kind of a visual representation also of this. So let me go back to my slides very quickly here, just so we can see better. So basically, you have this app host project, right? And this project is defining that we have, in this case, we have the API service, project resource. We have the front end. This is the other project resource. And of course, we also have, in this case, in this example, it shows cache. In our case, we have currently our PostgreSQL database, right? So you can have like, I guess, unlimited set of resources that are depending in other projects in here. So you can define these relationships between them, right? And so, and indeed, web frontend has been configured to also be able to talk to the API service, right? And also, in this example, web frontend needs a connection string to talk to the cache. In our case, it is the API service that needs a connection string to talk to the PostgreSQL database, right? And so, yeah, so that's that. And now, now that we have that, we are pretty much ready to go ahead and run this. And now, if you're curious also, you could also go, let me do F12 in GameStore.API, just so that you can see that this is kind of a metadata that has been auto-generated for you that AppHost is going to be using to be able to locate, right, the other projects from AppHost, right? And this is what enables all of these nice intelligence that's over there. Right, so now we're ready to get started and run this application locally in .NET Aspire. So let's go ahead and do that. Right, so let's go and do let's go into GameStore AppHost. And the first thing I'm going to do is that, I've been running this PostgreSQL Docker container in my box because I needed it. But now I don't really need to keep running my own container here because Aspire is going to take care of that for me. So if I do Docker PS, I'm going to see that we have the Postgres container right here. I'm going to just say Docker stop Postgres so that we don't have any more containers here, so it's empty, right? So that's great. And so what we can do now is just say .NET run, and that's going to go ahead and start our Aspire application. All right. Now, the app host is not just a project to compose your application. It happens to be that it also doubles as kind of a dashboard that you can use to explore all of the components of the app, right? So let me show you that now. So if we go into this endpoint, I think, yeah, this one over here. So let me just click on that right here. Yeah, there it is. And so let's put it up into another tab over here. There. So this one here is and let me see if we have, let me do a little bit more zoom. We can see better. There. All right, so maybe that's too much. Let's do a little bit less. All right, so this one here is a kind of a dashboard that resembles everything that's related to your cloud native or to your distributed application. In this case, as you know, we have two projects, the backend and the frontend right there, right? And so you can see the source code over there. But there are interesting things here. Let me actually zoom out a little bit. Like things like, for instance, here you have the endpoints of each of the applications, right? So if I just go ahead and click on this one, that's going to pop up, well, the homepage for the backend, right? But of course, we don't have anything in the backend. So what we should click is actually for the one for the frontend. So let's click on that one. And as you can see, here it is. Here's our frontend now running inside .NET Aspire, right? And as you can see, it is able to use the Docker container that Aspire stood up, right? So the data, by the way, I do have code to initialize the database with these 5 games that you can see here. So anytime the application starts, it just runs a migration and it just seeds this data here. That's why we always are going to see these 3 games here. So it's just for development and testing purposes, right? So you would not do this for production application. So, but yeah, the games are right there, right? The application is functional, right? We are not, I mean, we can do search. So if you look for this, that should work. So that works just fine. But we cannot really, actually, we can add games. So let me show you that we can add a game. So we'll say Super Mario, and let's do this, and let's do that, right? We cannot just yet add images because we need to add another component for that. But let me go ahead and just save it just to show you that it works. Right, it's right there. It doesn't have an image yet, but it's working, right? So your application is now running in Aspire without knowing exactly how the client has to talk to the server. I mean, how the frontend has to talk to the backend, right? Or the backend doesn't know exactly how to talk to Postgres. But even then, Aspire is making all of these connections for you so that everything just works, right? And that's really cool about this project. So that's that. But then, if you want to know more about the environment where each of these projects is running, so you can go, for instance, for backend, you can click over here. Where is the environment? So you click on that, and that's going to show you all of the environment variables that have been defined by Aspire for your application, right? And so, as you can see, right here is the connection string, right? So this is the connection string that is being used or that has been generated and prepared right there for your application to be able to talk to PostgreSQL, right? So you can see it's a randomly generated password, random port, all of that was defined directly by Aspire, and it's being sent over from the app host into the API project, so that the API project can talk to PostgreSQL, right? So you don't have to worry about the connection string and stuff like that, right? And there's many other values there. It's interesting also to see the front end. If you see the front end over here, you're going to see a bunch of things, but among them, you're going to also see down here, so notice this, right? So these ones here are the endpoints that have been defined so that your your front end is able to talk to the backend without knowing where it really lives, because Aspire is going to generate the host, the ports, all of that's going to be generated on the fly, so you don't have to worry about those things, right? So you can see that here is the real port that was defined for local development before, but it's not going to be used. What is going to be used is what is done here, right? At least for the backend. And so, yeah, so that's that. But also you can see other things, right? For instance, you can see the logs, right? So for the backend, if you go ahead and click over here, you can see the logs for everything that's going on in the backend. And as you can see, one thing that's interesting is that initially when the application was trying to start, the Docker container was just not ready. It takes a little bit of time for it to be up, but yet we were already trying to explore the data in the application, right? So what happens here is that you can see that because the application has been prepared to deal with this with resiliency. Anytime we try to connect to the database, it fails because it's not there, it's not ready. So it tries again and tries again and tries again, and eventually the application actually connects to the database and is able to get started, as you can see right there, right? So all of those details about the application you can see here in project logs. You can switch also to the front end, and you can see everything that's going on with the front end over there, right? So that's pretty cool. And then you can go into containers. Here's where you're going to see all of the containers that have been connected for your distributed application. You can also see the environments. You can also see the logs for the containers if that is interesting to you. It's right there. And then you can see, like you said, you can see logs for the project, for the container. I'm not going to take a look at executable right now. There's also structured logs here, right? So if you're using structured logging, you're able to start looking for every single, key that has been defined for your logs, right? And you can, for instance, you could go into level. You can see, well, I want to see all of the errors, if there's any errors right now. Warnings, we don't have warnings, or information. That's what we have mostly here. You can also do all sorts of filters, right, on different type of the different keys that has been set in your structured logs. You can look for that, and you can start looking, yes, it contains this for some value. Or for instance, I could say I want to see all of the post requests. So I'm going to pause here, and that's going to go ahead and filter the logs just to see into the posts, right? So yeah, so that's neat. And then you can also see traces. That's also pretty neat. So if we go on the left side into traces over there, what you're going to find is that we have here a series of all of the traces for the different operations that have been performed between the front end and the back end across application, right? And so this is super, super important for cloud native development, because you're going to have many services talking to many services, and many times you need to trace, right, what's going on across all those services. And so, for instance, let me see if we can find one of these, one of those posts that we created. For instance, let's try with this one over here, right? So what you can see here, if I collapse this, you can see kind of a timeline of execution that started with the front end, right? It starts with the front. I mean, this is kind of the full time on the front end. So front end sends a post that got a 201 as a response, and then it goes into the backend that is going to also go ahead and talk into Postgres, right? So even Postgres is resembled here. And as you can see exactly how much time each part of the operations took across the application, right? So in this case, it's super simple. It's even local. But imagine this kind of visualization when you have a much more complicated application, right? It's very useful to detect where are those bottlenecks in time, right? And it also can show many more interesting information. I'm going to show you later on here. But that's very neat. And as you can see, we have many traces across different execution of the application, right? And so lastly, we also have metrics, right? So if we go, let's go into, let's say, into backend, where you can see here, and let me collapse this for a moment, you can see the different metrics that have been published by either ASP.NET Core, or in this case, notice here, this is the MPG SQL provider, or the component that comes with Aspire that emits this different metric information, right? So you can see what's going on with the application. So for instance, you can pick a HTTP server request duration over here, right? And perhaps we can run a little bit of more stuff here. So let me go back to the home. Let's refresh this, refresh, so we can get a little bit of more data. Perhaps let's go to the next page there, right? So now we go here, right? So now we have a little bit of metrics, and these are very close to real time actually. And this is going to give you kind of a preview of what's going on with the application, right? In this case, what we're seeing is the request duration, right? So where your P50 means that kind of on average, our requests are taking, as you can see here, 0.01, I guess those are seconds, right? 0.1 seconds. And then P90, most of the requests are taking 0.025 seconds. And so still very, very good, right? So much better. So that is kind of a preview of what you're going to be able to kind of see in your application later when you deploy it into the cloud, right? And just like this, there are many other things. And as you add more components, you will be able to see more things in this dashboard over here, right? And you can filter by time and stuff like that, right? And so, yeah, so that's what you can see, you can do with this dashboard, which is super, super useful, right? But I think at this time, what we have to do is to finish adding the other components for our application so that it can actually also do the images that have to be sent into Azure Storage. So how do we deal with Azure Storage? So let's go back into our VS Code over here, right? And let me go ahead and just stop my app host. Before we start introducing the components for storage, what I want to show you is how this app is actually using storage, right? So if we get out of here for a moment and we go back, I think this is the backend. We want to go, so it is the front end that has a dependency on storage. But if we go back into param.cs over here, let me open param.cs and our app.json. What I want to show you is that in param.cs, what we're doing is we're creating this singleton image uploader, which is the one that's going to receive an instance of the blob service client. So this is a class offered by the Azure SDK for storage, right? And what we do here is that we provide the blob service URL, so the URL of the service in Azure that is holding the images in this case, and then we also use the default credential, default Azure credential. Now, this component here, default Azure credential, which is provided by the Azure Identity Library, allows you to create an app that does not need explicit secrets to be able to talk to that Azure service. What this does is that when the app starts, trying to talk to Azure, it is going to try to pull in the credentials from many places, right? So it's going to start trying, okay, so am I running perhaps as a with managed identities in Azure? I'm going to try to use that. If that's not available, maybe I'm running in a local box. I'll try to use the credentials of the Azure CLI in the box of the developer, or perhaps credentials for VS Code, or that could be like certificates and things like that, right? So because of this, this application is able to talk to storage without providing any credentials. So in this case, all it's doing is just using my credentials to be able to talk to Azure Storage. Now, what's important here is that in order for this to work, you have to make sure that you have the right permissions. So I want to show you very quickly here. Here's my Azure portal, and here's my storage account. So this is not the storage account that we're going to be using for Aspire. This is the one that I'm using just for local development. You still need something for local development in this case. And then if we make this a little bit smaller, perhaps, we can see the elements on the left side. You're going to see that in access control, I have one very specific permission, so role assignments. You're going to see that my account has this one permission here. So storage blob data owner. So it is very important that you set either this permission, there's other less permissive permissions, but you need specific permissions to be able to interact with storage by using this default credential provider. Otherwise, it's just not going to work. It took me a while to figure that out. So make sure that you add this or the right permissions in your storage account to be able to use it in this way. All right. And so, okay, so that's that. And now where is the actual connection string? So if you go back into app.json, you're going to see that we have this connection string here that we named just blobs right now. That currently it is pointing directly into my my developer storage account. But later it needs to start using the one that's going to be provided by Aspire, right? So we need to change this to that different model. Right, so let's go ahead and figure out. Okay, so how do I do storage with Aspire? We're going back to this page. All you have to do is just look for. So let me collapse this. We're going to go into storage, blob storage, and this is going to provide us with the right NuGet package. As you can see, here is the right NuGet package. So let's go ahead and copy this, and let's go back into our project over here. So let me open up my project file. In this case, the front end. And what I'm going to do is just get rid of these two project package references because we don't need them anymore. Remember that we're using wrapper packages that bring in everything we need to deal with storage. And then let's go into, I think it's the other one here. Yep. So in the front end, let's paste that .NET package with that Aspire NuGet package. So that's going to bring in, like I said, this is a package that has additional instrumentation, additional telemetry, additional resiliency to talk to storage in this case. And you can see it has been added over here. And because of that, we can replace all of this stuff over here with a brand new call that is going to be the following. So let's see, we're going to just one more line here that is going to say use builder.azure blob service, and here we still have to provide what is going to be the name of that connection, right? In this case, it's still blobs, right? The one that we're using so far, blobs right there. And because of that, we don't need this anymore, and we still need to add a singleton for our image uploader. And I can show you that image uploader very quickly here. This is a very simple class that takes a dependency on blob service client from Azure Storage, and it just has one method, upload image async, which is the one that takes care of uploading those images into Azure, right? So what we want to do now is just to add a singleton. We don't need to be creating explicitly. We just want to provide the interface and the concrete class like that, and that will do it, right? So whenever the image uploaded is needed, it's going to be using the dependencies that have been injected by the brand new method from .NET Aspire. Now, the next thing is that from here on, our front end should not be tied anymore to a very specific storage account. So that means that we cannot just say game store 01 here. So we want to switch this into a convention that's supported by .NET Aspire that is going to be, and let me just copy this to not mess up. You want to put here the account name. So account name is going to be replaced on the fly by .NET Aspire, right? So this is the actual string that you want to have here, right? So that's what you want to do at the level of your front-end project. Now we have to go into the host, the app host, and into app.json. And that is because here we also want to define that connection string. And this is because we need it for the purposes of local development, right? Because it's not magic, right? So we still need to figure out, we have some sort of storage account in this case to be able to talk to where we're in local development, while in the cloud, it is going to be using the other storage account provision by Aspire. Now, let me just copy this line over here very quickly. I'm going to copy that over here. And if we remember, the account that we were using is actually named as GameStore01, right? So now the connection string is in the host. The frontend has no idea what actual connection is going to be used. The host needs to send over those connection details into the frontend, both in the local box and later in the cloud with the provided artifacts. And so now let's go into the actual host over here. And what we're going to need in order to add this additional resource for storage is we're going to need a new NuGet package. So let me go over here into my app host and the NuGet package. And actually, I didn't find this in the documentation. I found it somewhere else. So let me show you what package you're going to need. So .NET add package. The package is named aspire.hosting.azure. Okay. So this one here allows you to start using some new NuGet packages for new resources that are specifically kind of for Azure. So back into our app host, what we want to do now is just like we're defining Postgres here, we're going to define the blobs service, right? It's going to be builder.add-azure storage, right? And then we can name it anyway. So let's just name it storage over here. And then we want to provide the actual resource that we need here, which is blobs. We're going to be dealing with blobs. We're going to say add blobs. And then what is going to be the actual name of the connection? So that one has to be the one in app host. Remember that we said in app.json, we said blobs. So blobs is the one that we're going to need over here, right there. And that defines our blob service, right? Now, of course, who needs the blobs? The blobs are needed by the front end. So we're going to say down here, we're going to see with reference, right? You can chain many of these as needed with reference into blobs, there. Okay. Yeah, so that should do it. So notice that we keep composing the application here, right? To have all of the components needed so later to run as a complete cloud native application in the cloud. So that's that. So what we're going to do now is just run the app host. It's going to run again, right? And so let's go back into our dashboard. Okay, over here, we're going to go ahead and refresh this. Okay, it's refreshed, so we're back. And so at this point, we should be able to go ahead and actually start using images in our application. So what we're going to do before doing that, let me just go ahead and open up the logs for the front end because I want to show you something that may happen here. So let's see. So here we're back. Let me go into the home page. Here we are. So let's go ahead and create a brand new game. So once again, let's go for Super Mario Bros. 3. Okay, so it's going to be 1988. Right, now let's choose a file this time, and it's going to be this file here, and let's hit save. Now, one thing that you're going to notice here is that this is actually going to take a while, right? So I'm actually just waiting here, waiting for it to complete. So what's going on? So this is where Aspire logs are going to be helpful. So you go back here, you're going to see that there are things going on, right? So notice this. So you can see that our application is trying to access Azure identity, right? To be able to retrieve an access token to be able to talk to Azure Storage, right? So first, it is trying to actually talk to what is known as the instance metadata service, right? In the local box, right? I think the IP, I cannot find the IP quickly here, but the way it works is that first it tries to talk to the local host in the cloud, and then it realizes, you know what, I'm not actually in the cloud, so I need to figure out some other way to get a token, right? So it just keeps trying and keeps trying, and then after a while, it realizes that there is actually an access token in my local box, right, via my VS Code session or via my Azure CLI, and that's how it is able to actually talk to Azure Storage, right? So, of course, before the demo, I did log into Azure via Azure CLI and also via VS Code, and that's how it's able to connect to the storage account. But it took a while. Right, and if you didn't understand why it took so much time to provision the game, you can easily just go back here, look at the logs, and that's going to reveal what's going on. As you can see, we go to 2, and the game has been created, and this time by using directly the connection provided by Aspire. Now, if we close this and if we go back into projects, notice this. So there is there's a notice of there's an error right there, right? And so if we click on this, let's see. Yeah, this took us into the structured logs right here, like you can say. So the structured logs, there's something about, like I said, this is managed service identity. MSL is a library. There is a trace that we can click, and we can click there. And this trace is now much more interesting than before, right? Because now we can see, okay, so indeed, we tried multiple times, right, to talk to different services to get a token from Azure, from Azure, so that we can talk to Azure Storage, right? So that's what happened here multiple times. Those are the errors, and eventually we actually got access to storage, as you can see there, and then later we were able to just upload the image, get back a response, and then later on just post the game into the backend, right? So super useful this trace here to understand what's going on even locally in your box. And so, yeah, and that pretty much concludes the creation of our application in via .NET Aspire. Your application at this point is pretty much ready. I mean, it is cloud native, but of course, it would not be really cloud native until the application actually gets into the cloud, right? So in the next video that you can see here, we're going to go ahead and take this application and actually deploy it into the Azure cloud by using the .NET Aspire tooling. So I'll see you in that next video.